a lot in the news about percent increases. So let's talk about that because it's connected with what we are learning right now, and that's exponential growth. So let's say that the number of people being infected grows by 20% each day. I'm just making up this, okay? So let's just see how we would figure out how many people in all would be infected each day, okay? So let's just I just want to explore this and then we'll talk about some shortcuts. So let's say X is my number of days, and let's say that Y is my total number of people infected as the days go by, okay? So here's day 0, our starting point. And let's just do a few of these days, and then we'll see what kind of shortcut. So let's just say that I'm starting with 100 people, just to make our numbers easy. So let's say at the time 0, let's say we're starting with 100 people. So after one day, we're going to have 20% more people. So let's think about how we would do that. Well, we have our 100 people. And we are going to multiply that by 100% because those same people are going to be infected the next day, plus my 20% extra. Does that make sense? So let's just say that's going to be my 100 people times 120%. All right, percent, remember that's a little symbol that means just out of 100. So 120 divided by 100, you can do that in your calculator, or the little trick is you move your decimal 2 places. So 120% is 1.20 in decimal land, or of course you could write that 1.2. Well, 100 times 1.20 is going to be 120 people. Okay, so after one day, I now have 120 people, which makes sense. We probably didn't have to do all that math because 20% means 20 out of 100. So if I started with 100 people, we know we're going to add 20 to that. But here's the question. Am I going to now add 20 people and have 140 people here and then 160 people? And I hope you're saying no. We're not just going to be adding 20 people, We're not adding 20 people each day. We're adding 20%. So what we have to do now for this next day, for day 2, so this was day 1. Here's day 2. For day 2, what we're going to have to do is we're going to have to start with our 120 people and multiply those 120 people times my 120%, which is, in this case, 1.20. Okay? Now, some of you might be able to do this in your head, but if not, you can certainly grab your calculator, do 120 times 1.2, and you're going to get 144 people. 144 people for day 2. Okay, so my first day I added 20 people. My second day, look, I'm adding 24 people. So I'm adding more people. Hey, let's try day 3. Let's try day 3. So day 3, all right, I had 144 people the previous day. I'm multiplying that by 1.2 or 1.20. So 144 times 1.2, that's going to give me about 172.8 people. right? We're getting into decimals, which of course is weird when we're talking about people. So we'll say about 173 people. So you see, I'm adding more and more and more people. And that's why exponential growth looks like this. Because as the days go by and your number of people that get infected, more and more people get infected with every day. This is what exponential growth is all about. Okay? Now the question is, would there have been a shortcut? And I think the answer is yes, of course there's a shortcut. There would have been a way that I could have figured out all of these without doing each day. So for example, if I wanted to come in and say, all right, I don't want to go all the way, but let's say after 10 days, how many people would be infected? Well, this is when I'm going to write an equation. And my equation is the shortcut. And of course, it is going to be an exponential equation. So if I'm talking about y as my number of people, we're going to start with 100 people. And what did I multiply by over and over again? Oh, I kept multiplying by 1.2 or 1.20, right? I multiplied 100 by 1.2 once for day 1, twice for day 2, 3 times. So what I'm going to do is, you guessed it, put an x up there. And this is my exponential equation that shows a 20% growth each day. So when I plug in a 1, let's just check. Day 1, I'm now going to put a 1 in for my x, and sure enough, I get 100. Day 2, I'm going to put in a 2 for my x. And if you put that into your calculator, you're going to get 144. Day 3, I'm going to put a 3 into my exponent for my x. You're going to get 173. So let's scoot ahead and let's see what I would get on day 10. Well, all you have to do is put a 10 in there. Remember, that means you're multiplying 100 times 1.2 times 1.2 times 1.2 times 1.2 10 times. The exponent gives us a shortcut for doing that. So in my calculator, I'm going to put in 100, parentheses, 1.2 or 1.20, the little caret, and then 10. And boy, oh boy, that's a lot of people. Around 619 people. Right? Let's say after 1 month, let's say day 30, I'm going to put a 30 into that exponent. And again, you're going to put that in your calculator. And holy cow, that's a lot of people. 2, 3, 7, 3, 8, about 23,738 people. So that's the thing that's crazy about exponential growth. Right? It can move very, very quickly. So basically everything we talked about with a percent increase would be the same as a percent decrease. The exponential equation is a shortcut for doing it step after step. The only difference, of course, is that your base of your exponent, of course, has to be a number that when you multiply times that number, you're going to get a smaller outcome instead of a bigger outcome. So think about what has to be true about this number in here. And yeah, you're right. It has to be less than 1. So let's just say we have a scenario. Let's say we have 100 bacteria. And let's say that there is a 20% decrease in the number of bacteria each day. Okay, so I could do what I just did with the increase and come up with my chart, but let's just cut to the chase and let's do the shortcut. So I know I'm going to have 100 bacteria, and I know I'm going to be multiplying by 100%, right? But I'm losing now 20%. But what's 100% minus 20%? Oh, it's 80%. Percent again means out of 100. So in decimal land, I'm going to write 80% as 0.8. So my model for this situation would be my starting population, 100 bacteria. I'm going to be multiplying by 0.8. If you want, you can put a 0 in front just to make it more obvious. And I'm doing that each day, where x is the number of days. So it'd be 100 times 0.8 times 0.8 times 0.8 x times. So I can just use that now to fill in my chart. So let's say day 0, day 1, day 2, day 3. Day 0, I know that I have 100 bacteria. Day 1, I'm just going to put a 1 in for my exponent. So it's going to be 100 times 0.8, the little caret to the 1. Oh, I guess I didn't need to do a caret. I could have just done 100 times 0.8. Or you could have done that in your head and thought 20%, well, since I'm starting at 100, 20% of 100 is 20, so I'm losing 20 bacteria. All right, so now I'm going to do the same thing here. Day 2, you can put that in your calculator, 100 times 0.8 squared. And again, some of you might try to do this in your head because that's a fun challenge. So you'll have 64 bacteria left on day 2. Let's do one more. Day 3, you're going to be plugging in a 3 for that x for the number of days. So it's 100 bacteria times 0.8 raised to the 3rd, and that's going to be 51.2 bacteria. And again, we can see that since I'm multiplying by a number between 0 and 1, that my total number of bacteria is going down, 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 just like my exponential decay does.